What is up, YouTube? Welcome back to another episode on Code with Annie. And in this particular episode, we're going to take a look at the implementation of quicksort algorithm in Java. If you recall in the last video, I explained you the algorithm of how quicksort works. It picks up something called as a pivot element and it tries to sort the elements surrounding the pivot in such a way that all the elements less than the pivot will fall to the left side of the pivot and all elements greater than the pivot will fall to the right side of the pivot. Right? For example, if we pick up the pivot element as 12, at the end of this sorting, we will have been left with this particular array where all elements less than 12 are on the left side and all elements greater than 12 are residing on the right side. Okay, so this was the quicksort technique, and to implement this in Java, I have written a code here which is purely based on whatever I've explained to you in the last video using this approach. This code that you see here might not be the same one that you will see if you search for quicksort algorithm in Java in Google, because if you find any website that is explaining this algorithm, it will be slightly different. Mostly all of them will be copy paste of one another and all of them will look very similar, but this particular algorithm that I'm explaining here is something that I've written on my own, following exactly what I've explained to you in the last video. Okay. So this might look a little bit lengthy because I've segregated the functionalities into different methods. Basically, you have a quicksort method, you have a partition method, you have start from right, and you have start from left. Okay, and you have one more condition called should exit loop. Now, without further ado, let's delve into this video because this might stretch beyond 10 minutes, but let's see to it that we get this concept clear. Now, I have an array of, actually it's a little big array. It has quite a number of elements in it in random order. If you also observe, there is a duplicate element here. There is 10 here and there is again 10 here. So it has duplicate elements as well. And as per sorting, the 10 should come together. Okay. I'm calling the quicksort method here with it accepts three parameters. It accepts the start position from where I want to start and the end position where the end pointer should be and or last element should be, and the array itself. So I'm calling with 0 array.length -1, which is the last position of the element in the array and the array itself. Now what we do here is we go here to quicksort method and you see that if start is less than end, why do we have this condition in the first place? We have this is because you don't want to continue sorting an array which has only a single element, right? So once you reach a point where you have divided the array initially into left and right, and then the left itself becomes divided into again left and right, and so on and so forth until you reach a point where you have only one or just one element, for example, then in that case your start will not be less than end, right? So you want an exit condition where you want to say that okay, everything is sorted. By the time it reaches this condition, it is assumed that the entire array is completely sorted. So initially we know that the start is 0 and the end is the array.length -1, so that is always start is going to be less than end when you start the algorithm. We go ahead and find the partition index, which is basically calling a method called partition with the same parameters start, end, and the array. Now what does partition do? Now if you recall from my last video, in the explanation I mentioned that if I pick up the first element as pivot, which is what we are going to do here in this algorithm as well, I'm going to say that the pivot element is always going to be the first element in the array. In this case 10 is going to be the pivot element. So I'm picking up the pivot as 10, therefore my pivot is pointing to the first element, my left pointer will point to the first element, my right pointer also will point to the last element of the array, and my sorting or comparison will start from the right side because my left and pivot are pointing to the same element. I'll start picking up elements from the right side or the last position of the array and go in the decremental order to compare the elements. The same thing I'm going to do here. I just called it in a different fashion. I'm saying that start from right. When I say start from right, what I mean is my right index is going to be the end index. My left index is going to be the start index. My pivot is also going to point to the start index and the array, which is exactly what we have here, right? We have the left and pivot pointing to the same element and the right pointing to the last element, which is what we call in start from right. Now, the moment I enter this method, what I do is I start picking up the first element on the right side, which is in our case going to be 199, and it starts to, once it picks up the element, my right pointer is now pointing to the last element, okay, which is going to be 199 in this case. So right and 199, right is pointing to 199, left and pivot are pointing to 10. Keep this in mind. And the algorithm starts here. It checks that if array of I is equal to, this is the exit condition for this for loop. what we are checking is if I have reached a point where my right element and pivot element are same and the right position and pivot position is also same, meaning I have iterated all the way till I reached my pivot itself. If that is the case, right? If that is the case, just break out of it. Just come out of it. Okay. This is one exit condition. Keep this in mind. If my elements in the right, I mean, whatever I'm picking up from the right, if that matches the pivot and the position also matches that of the pivot position, that means I've reached the exact pivot element that I've picked up. I'll just break out of the loop. Otherwise, I'll check that if array of I is less than array of pivot, in case we find any element which is less than the pivot on the right side, we just have to swap it, right? That's the algorithm, right? If we see something less than the pivot, just swap it. So the same thing, if we see anything less than the pivot, just do a swap. So once you're done with the swap, what we will say is the pivot will now point to the move to the right pointer, right? So if you remember, we did a swap between 5 and 12, and after that, what happened? Left is still pointing to element 5, right is now pointing to element 12, pivot is also pointing to the same pointer where right is pointing, because now 12 has switched its position. 12 came from here to here, which is nothing but the right pointer's position. So for the right and pivot will now point to the same position, whereas the left pointer will be on the first element, whatever got swapped there, right? So that's why I'm just doing the same thing here. I'm just trying to equate the right and the pivot pointers. I'm just saying that pivot is equal to right, and I'll break out of the loop. Moment I do a swap, I break out of it. I break out of the entire for loop. So there are two cases by which the for loop will get broken. One is when you have reached the pivot element itself, and one is when you have done a swap on the pivot element. The moment I do a swap, I break. The moment I reach the pivot, I break. Okay. The once I break out of it, the for loop, I'll come out and I'll see that should I exit the loop. Why should I exit the loop? Because if you remember the exit condition, it is basically when left, pivot and right all point to the same element and same position, right? Then I have to exit. So I'm just checking should exit loop is basically saying if left is equal to right and right is equal to pivot, meaning all of them are equal to each other, that's my exit criteria. That is exactly what I mentioned here, right? The very same thing I have coded here. I'm saying that if that is equal, just come out of it. Okay. So should exit loop, then just return the pivot, which is the position. I just need the index of the pivot. Okay. So that I can do the sub-array partitioning, because once I see the index is basically, let's say this is the index is 2, right? So when I pass this index 2, I'll get two sub-arrays 5,1 and 14,60. And these two will have again a quicksort applied on them, with 5 being the pivot for 1,5, 14 being the pivot for 14,60. Okay. So that is what we do here. Start, partition index minus 1, array, partition index plus 1, end, array. Right. Partition index minus 1, start is 5, partition index minus 1 is going to be 1, 5,1, this entire array. Another quicksort on partition index plus 1, which is nothing but 14, 60, this entire array 14,60. 60 is position, that is. Okay. All these are positions. Okay. So we come here, and if we should exit the loop, we just return the pivot position, the last position of the pivot. And that is the reason why the pivot's position has also to be updated accordingly, because by the end of this iteration, wherever the pivot is sitting would be either the pointer where the right pointer is pointing to or the left will be pointing. I'll come to the other method as well. So return the pivot. Now, once you do this pivot return, okay, if you reach the condition where you should exit the loop, you will return the pivot. In case you're done with the swap, you break and you see that exit condition is not yet met, which means you're not completed. You just did one swap, which means you just did this and you have got this. You have to continue doing the swapping, right? You just did one swap. You have to continue moving the pointers subsequently. Now you have done a swap. Moment you do a swap, now the left pointer will start moving. Now you'll start moving from this side. You're done with moving to this side. You did a swap. Now you start again moving from the left side, which is what you have a method here. Start from left, right? Remember, as soon as I do the swap or as soon as I break out of it, I will check the exit condition. If my single pass of quicksort is done, I'll return the pivot. Otherwise, after I'm done with the swapping, I will start from the left side. Now, this is the case here. Left and Left is pointing to 5, 0. Right and pivot are pointing to the same element. So same thing here. Left is pointing to the first element. Right and pivot are pointing to the same thing. So again, we check the same clause. Exactly what we did here, we will do the same thing here. Same logic. Just copy. Just put it here. Just you have to change all the right to left. Now left will be assigned to I, because you have to keep track of the left pointer as well, right? Same case, right is assigned to I because you have to take care of the right pointer. Once you start moving from here, right, when you go to 14, your right pointer will also move to 14. That is what we are trying to do here. Right is equal to I. Same thing, when you start moving from left, let's say you start moving from 5, then you move to 1, right? So the left pointer has to be updated. What you're doing here, right? So let's say left is pointing to, where is that? Yeah, 1, 1. Now left is pointing to 60, 2. So you have to keep moving the left pointer as well, right? So when you move the left pointer, the same thing. So what I'm trying to say is, whatever logic you have written for the right, just copy the exact thing. Only the for loop will change now because you're not going in the reverse, you're going in the forward direction. So it will be I equal to left, I less than array dot length, I plus plus. Okay. You will go from left equal to I. You'll put left equal to I, and then you will check that if array of I is equal to array of pivot, exact same condition, whatever you checked here, array of I equal to pivot, just break out of it. Otherwise, if it is instead of less, it will be checking for greater, because all the elements greater than the pivot will lie on the right side. So since you're starting from left, if you find something in the left side which is greater than the pivot, you have to do a swap. Exact opposite of what you do here. Same code, everything is same. This for loop will change direction. Okay, and this condition will change direction. This less than will become greater than. That's it. Nothing else will change. The exit condition is same, and then once you're done here, as I mentioned, once you do a swap, you will again start from the right side, because the pointer will now sit on the left, because you have swapped to the left, right? So pivot and left will point to the same element, so you will start again from the right side of the array. So you keep doing this process between start from right and start from left until one of them satisfy this should exit loop, wherein you will return the pivot element. So once you return the pivot element, you go ahead and you get the partition index here. After the very first call, you will get one partition index, which will basically would have divided the array into two halves, one with a pivot in the middle and all the elements less than pivot on the left and all the elements greater than pivot on the right. Based on this partition, again I will call the same quicksort algorithm with the start and the new position, which is n will change. N will be index before partition, comma array, and the other quicksort will be called on the other half of the array, which is after the partition element, whatever is there, that element's starting position, end of the array, and the entire array. So quicksort is called again 2 times, one after the other. So this process will keep repeating in a recursive fashion, one after the other, and entire array will be completely sorted. So let's run this program and see the result. And so you can see 1, 3, 5, 10. 10, see I mentioned 2 10s, right? So both of them will sit together. 19, 20, 55, 64, 88, and 199. Right. So this algorithm might be a little bit of a stretch. If you are looking at this Java implementation, you may not understand it in the very first go. I'll give you a lot of time to probably write this code. I'm just gonna stop explaining now. I want you to focus and probably take down this code somewhere. Just try to write it. Pause the video if you want. Just write down the logic that you see here. You can go through the logic, debug it on your own, and you will be able to get what I'm trying to explain. Right, so this is your main method, this is your quicksort, these are the condition, this is the partition method, which basically will trigger the start from right, because our pivot element is going to be the first element in the array. Then this is the start from right code, and if you take a look at this, you can pause this video here and you can write this entire code down. Then you have the start from left call, then this is the start from left code. I'm pausing here as well for a slight moment. You can pause the video and take down this logic as well. In fact, you don't even have to write this by yourself. All you have to do is just invert the conditions that are present here. This can be further refactored, but that is up to you. I'll leave it to you guys. But what I'm saying is, once you have done the start from right, start from left is just an inversion of all the conditions, with just the pointer right becoming left in our case. Okay. And when you say start from right, you will call the right and then the left and then the pivot and array. When you call start from left, you will call the left first, then the right and pivot and array. That's it. And should exit loop is this particular condition, which is nothing but a very straightforward condition where the left, right, and pivot all point to the very same element in the array. Finally, of course, the print array method, which you are all well aware of by now, just print out the elements in the array, right? So that's it for this particular video, and if you liked it, do hit the like button, subscribe to CodeWithAni if you haven't already. If this video stretched beyond 10 minutes, I apologize, but this video definitely requires some amount of detailed explanation because of the number of methods and the complexity involved. If you look at the complexity, it's not much, it's very simple, but it is very useful. And if you like this particular approach of writing the code, you can follow this, or you can follow what's there on many other websites that are listed out there. Share with your friends. I'll see you guys again in the next video. Bye bye guys. Thank you.